Hi guys, my name is IBM and I am trying to answer a question which was asked by a friend of mine called Hamid. So hail. He wanted the clarification on this question here, so I'm just going to go back and record a short video on his behalf. So here is this force. This question is under force, then stand pressure, that is under multiple choice questions. And I think it's on page around page 15. So I'm going to page 15. Okay, so this is the question which he wanted me to clarify. Let me try to clarify it again. So these are two forces acting for x. If I say this is causing a clockwise moment and this is also causing a clockwise moment about the center. So this center, the distance between the the force and the center is approximately 25 centimeters. So for x, 20 newtons is going to cause a moment which is going to be 20 newtons times the perpendicular distance from the center. I'm assuming these forces are causing rotation about the center, which is 25 centimeters. So this is going to be times 0.25 meters plus 40 newtons is also going to cause a clockwise moment about the center. So this will be 40 newtons times perpendicular distance about the center, which is 0.25 meters. So we have the total moment, which is clockwise, as being 20 plus times 0.25, which is 5 Newton meters, plus 40 times 0.25, which is 10 Newton meters. So that means the total moment, if we add this is clockwise plus this is clockwise, that would be 15 Newton meters. So the moment due to x is 15 Newton meters, which makes B to be wrong. If I say x is equivalent to a clockwise torque of 20 Newton meters only, it means B is wrong. If I say y is equivalent to an anticlockwise torque of 30 Newton meters, I think this is also wrong. Let's verify for y. So for y, this is anticlockwise, but it is also about the center. So for y, for 20 newtons, it will be 20 times perpendicular distance, which is 0.25. That is to the center. I'm dividing 50 by 2. Then plus 40, which is 40 times the perpendicular distance, which is 0.25. It is also going to be 5 plus 10, which is 15 Newton meters, but this is anti-clockwise, yet this was clockwise. So it means it is wrong to say y is equivalent to an anti-clockwise torque of 30 Newton meters only. But then let's check A. X is equivalent to a clockwise torque of 10 Newton meters. We see 10 Newton meters was clockwise and a force of 20 Newton meters to the left. What does a force of 20 Newton meters to the left do? It will actually cancel out the 20 Newton meter, the 20 newtons. It will produce, if I have a force of 20 newtons to the left, assume you have a force of 20 newtons to the left, wherever you put it, it will cause a moment which cancel out the moment caused by 20 newtons. Or alternatively, a force of 20 newtons to the left would cause a moment of 5 Newton meters, but in the opposite direction to cancel out the 5, which was the other way around. Alternatively, you can also look at it like this. If I say x is equivalent to a clockwise torque of 10 Newton meters and a force of 20 newtons to the left, so it means I have x, here I had 20 newtons, and here I had 40 newtons. The 40 newtons alone would cause 10 Newton meters, which is clockwise. Then we need to cancel out this 20 newtons because it was to the right. I need a force to counter this to the left, which would be in the opposite direction, so that this moment, the moment of this and the moment of another 20 newtons to the left cancel out, so that the resultant is just 10 Newton meters. Without this force here, the resultant would be 15 Newton meters. But with this force here, the resultant would be 10 Newton meters because the 20 newtons to the right is cancelled out with the 20 newtons to the left, which we have added there. So the answer is automatically going to be A. If I check Y, Y is equivalent to an anticlockwise torque of 30 Newton meters. It can't be 30, it is supposed to be 15, but let's check the effect of 20 newtons to the left. 20 newtons to the left here, if I have 20 newtons to the left, it would just cancel out the 20 newtons or the effect of the 20 newtons. So this will be 20 newtons to the left to cancel out the effect of 20 newtons to the right. That means I remain with a moment of 40 times 0.25, which will be equal to 10 Newton meters. So if it was 10 Newton meters and a force of 20 newtons to the left, it would be correct. But since it is a 30, then this would not be correct. So I'm saying the answer is B. I don't know whether I've tried to make it clear. If not, I can still make it clear. Hamid, I think I have answered your question. Thank you. Bye-bye.